Hello. Yeah, in this video, I want to show you how to perform double bootstrap using R. Okay, the double bootstrap is the bootstrap. So for each bootstrap sample, you do another bootstrap samples of this bootstrap sample. Okay, so there's two loops, two layers of bootstrap. Main benefits of double bootstrap is it can get to improve the coverage accuracy for confidence intervals. So when you have a say 95% confidence interval, it gives you a formula or procedure to compute an interval given a sample. But if you do that repeatedly with different random samples, you get different intervals. The actual coverage, the proportion of interval covering the true value may not be exactly 95%. Okay. So that's what we call accuracy of confidence interval. And when you do double bootstrap, then this will be closer to we call the nominal confidence level, 95%, for example. Okay. And also, you can get more reliable inference because you're going to get more accurate estimate of the p-value that you use for significance testing. Okay. And it's also very good for more complex situation where you may have non-pivotal statistic. That is the statistic that may depend on other unknown parameters. And if you do double bootstrap, it's going to reduce the influence of those unknown parameters. Okay? And the main challenge of double bootstrap is the computational cost. If you think about it, your bootstrap sample, that's like the number of bootstrap samples grows exponentially. Okay, so usually we can only afford to do double bootstrap. You don't see triple bootstrap or quadruple bootstrap. One is the computation is prohibitive. Second is maybe after double bootstrap, the accuracy does not improve a lot. Okay, even you do more triple bootstrap or quadruple bootstrap. Okay. All right, so let's set a random seed and create a data, which is a random sample from a normal distribution. And if you look at this function called the double bootstrap mean, so we're going to do a function that is for calculating the double bootstrap estimate for the mean of the sample. Okay, so it's going to read in data. And the outer B, 1,000, inner B equal to 1,000. So these are the number of bootstrap replicates for the outer loop and the number of bootstrap replicates for the inner loop. And confidence level is 95%. Okay. So you can read line by line. First, you get the length of the data, and then you create two numerical vectors, outer means and inner means of the outer B and the inner B length. Okay, and then you do like a nested for loop for I in 1 to outer B, so that's the outer loop. You resample the data and put it in outer loop, outer sample, and then you calculate the mean of that outer sample and store it into outer mean vector. Okay. And for that, then you do an inner loop for J from 1 to inner B. Then you resample the outer sample and then put it in the inner sample. And then you calculate the inner sample mean stored in the numerical vector for the inner means vector. Okay. And then these will compute all the double bootstrap estimate you need to be summarized. Okay. So let's run it. You get the function read in, and then we do double bootstrap mean data. Okay, we use 1,000 and 1,000 for inner and outer loop, and 95% confidence limit. So let's run this. And it's computing. You think about it, 1,000 times 1,000, that's a million. So basically, we're calculating the million means. Oh, still not too long. It gave us a result. So we print out the result, you can see it has a double bootstrap sample mean estimate 4.971881, and then you get a confidence interval 95%, 4.54 to 5.40. Okay, and this is really probably the simplest double bootstrap example because we're simply calculating the mean. Okay, so you can do other statistics, for example, standard deviations, or you can do a bootstrap for a linear regression model, any other more complicated statistical estimates. But then the computational will be very, very challenging. Okay. All right, so this is a very simple example to demonstrate the idea of double bootstrap. And thanks for watching.